Hello and welcome to the Screencast, Modeling with Polynomial Functions. In this section, we study two important applications of polynomial functions. One, how they arise in finding optimal solutions to building containers under certain constraints, and two, how they can be used in approximating more complicated functions. Think of a soda can. Why does the cylindrical can have the dimensions it does? Once we've decided that the shape is a cylinder, we can study how the volume and surface area of the can depend on the radius of the base and the height. Indeed, if we think of a standard 12-ounce soda can, this tells us that the volume is fixed at 12 ounces, and we might ask what dimensions use the least amount of material. Problems of this type are called constrained optimization problems. We want to make one particular quantity as large or small as possible, subject to one or more constraints. One of the first examples we'll consider in this section is a problem such as, for a rectangular box with a square base, what is the greatest volume the box can contain if we only want to use 4 square feet of material? Well, calculus is needed to rigorously find the dimensions that generate this maximum volume. Polynomial functions enable us to develop and study the function that shows how the box's volume depends on a single variable. Polynomials are also useful because the curves they generate can be used to approximate other functions. One of the most important examples of this is the fact that non-polynomial functions like the sine of x and e to the x can be approximated by polynomial functions. Indeed, this is how calculators and computers are able to determine values like the sine of 0.3. We'll see that the sine of x can be approximated by the polynomial x minus 1 divided by 3 factorial times x cubed plus 1 divided by 5 factorial times x to the 5th minus 1 divided by 7 factorial x to the 7th for values of x near 0. And thus, the sine of 0.3 is approximately 0.3 minus 1 divided by 3 factorial times 0.3 to the 3rd power plus 1 divided by 5 factorial times 0.3 to the 5th power minus 1 divided by 7 factorial times 0.3 raised to the 7th power. Polynomials are the simplest of all functions in mathematics, and yet they find important applications in a wide range of settings, some of which we study in this section of the text.